Welcome to Networking and Health Information Exchange, Network Media, and Hardware Communication Devices. This is Lecture A. The objective for this lecture is to select appropriate hardware devices such as routers, switches, and access points to facilitate networking and data exchange, taking into account access and regulatory requirements. First, we will cover some general terms that you need to know when dealing with networking. Information can be transmitted in one of two ways in a network: analog or digital. An analog signal is a continuous signal, and it is hard to distinguish each character. Examples of analog signals are voice, analog clock, and old analog TV signals. With digital signals, each character is very distinct. A computer uses digital signals, zeros and ones. Other examples are digital clocks and digital TVs. It may be hard to tell the exact time on an analog clock, but with a digital clock, you can tell exactly what time it is. A couple of characteristics of a signal are amplitude and frequency. Amplitude is the height of a wave at a given period of time. Frequency is the number of times a signal changes in a given period of time. It is measured in hertz, Hz. The amplitude and frequency of a signal can be changed or modulated to represent data. For example, if we are using amplitude modulation, a big amplitude represents a 1, whereas a lower amplitude represents a 0. With frequency modulation, lots of changes in a signal over a given period of time represent a 1. Whereas fewer changes in a signal during a given period of time represent a 0. Amplitude modulation is used by AM radio. Electric sources like lightning could cause a 0, low amp, to become a 1, high amp. Signals that are produced by amplitude modulation are carried a shorter distance before degrading. Think of AM radio stations. Frequency modulation is used by FM radio. The signals are carried longer distances and are less susceptible to interference by other electric sources. Think of FM radio stations. The graphic on this slide is an example of amplitude modulation and frequency modulation for an analog signal. Data can flow in one of three possible ways in a network: simplex, half-duplex, or full duplex. Simplex means that data can only flow in one direction, like water coming out of a faucet. You can't send water up a faucet. Half-duplex means that data can flow in both directions, but only one direction at a time. An example is a CB radio. You can talk on the radio and listen on the radio, but only one of those things at a time. Full duplex means that data can flow in both directions simultaneously. An example is a 2- or 4-lane highway. Traffic travels in both directions at the same time. Full duplex allows multiple signals to travel simultaneously over a single media. This is called multiplexing. Full duplex allows more data to be transmitted at any given time. Bandwidth is a measurement of the difference between the highest frequency and lowest frequency that a media uses. Medium or media is the type of cable or wireless that carries the signal between devices. Bandwidth is theoretically the maximum amount of data that a particular media can carry. Throughput is the actual amount of data that is being transmitted on the media at a given period of time. Throughput is almost always lower than bandwidth. Bandwidth is important in determining the pipe that your data will be able to travel down. The bigger the bandwidth, the bigger the pipe. An example is a 4-lane highway. Bandwidth would be 4 vehicles, but if there is a wide vehicle taking up 2 lanes, the throughput would be just 3 vehicles. Bandwidth is measured in bits per seconds, BPS. Chart for BPS. 1 bit per second, BPS. 1,000 bits per second, kbps. 1 million bits per second, mbps. 1 billion bits per second, gbps. 1 trillion bits per second, tbps. Current technology has transmission speeds measured in mbps or gbps. Many things can cause errors during data transmission. These errors may cause the data to not be received at all, or they may alter the data that is received, so it is not the same as what was sent. Electromagnetic interference, EMI, and radio frequency interference, RFI, are caused by motors, power lines, fluorescent lights, radio or TV tower signals, or any other source of electrical or radio signals. EMI interferes with signals that are being sent electronically across copper cables, and RFI interferes with wireless signals. Attenuation is the loss of signal strength as it travels away from the source. An example is yelling in a canyon. Hello, 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 hello. Repeaters can be used to boost signal strength so it can travel farther. Crosstalk is when signals from one wire interfere with signals on another wire. Both wires are part of the same cable. Alien crosstalk occurs when signals from adjacent cables interfere with another cable's transmission. An example of crosstalk would be when a cordless phone signal is picked up by a baby monitor. Latency could be an issue in data transmission. Latency is a delay between the transmission of a signal and its receipt. This may cause a device to think that its signal has not been received, and it will resend the signal, causing excess traffic on the media. In order to have a physical network, we need media, a way to connect devices to the media, and devices to connect the devices to so they can communicate. Media or medium is what connects the network devices to each other. It can be a cable or wireless. Network interface cards, NICs, connect the devices to the media. Interconnectivity devices include hubs, switchers, routers, and wireless access points. A node is any device on the network that has an address, like an IP address, and can send and/or receive data. Examples of nodes are computers, laptops, printers, telephones, PDAs, tablets, or anything that you can connect to a network. Any node that you want to connect to the network must have a NIC. There are many different types of NICs available. The NIC you use must be compatible with the hardware of the device you are installing it in. For example, if the computer only has Peripheral Component Interconnect, PCI slots, then the NIC must be a PCI NIC. It must also be compatible with the media you will attach it to. For example, if you are connecting a laptop to a twisted pair cable, then the NIC must have the correct port for a twisted pair cable. Wireless networks are very popular today. One type of NIC is a USB wireless NIC. It can be used in laptops and desktops. Lots of cell phone companies offer wireless network plans and supply customers with wireless USB adapters so they can connect to a network. There are other types of wireless NICs like the one shown in the slide with an antenna attached. Just like there are many different types of cars, there are many different types of NICs. They will all get you connected to the network, but some will give you better connections than others. This concludes Lecture A of Network Media and Hardware Communication Devices. In this lecture, we have discussed transmission basics and network connectivity.